Oh, back to the States, yeah.
Yeah, excellent.
So that's the plan starting next year.
If they let him back in, he may have been gone too long. They may have.
I don't think it's him that it's the concern.
I would have revoked his citizenship by now. Stayed down there too
Hey,
long.
I'm still paying into the Social Security and Medicare system, so
Yeah,
I'm not sure they want to revoke that for me. They'll lose out on some money.
that's right. The U.S. has a good way of making sure you don't forget you're an American overseas.
Yeah.
Unlike,
Don't worry, if Trump gets reelected, he suspends all that anyway. Don't worry about it.
good. Well, he is a Republican, right? So no taxes, right? Revenue, government revenue. We'll just invade Mexico, right?
Just remember what happened when you tried to invade us, okay? It's the only thing we've got. 200 years later, it's the only thing we're holding to. So
Yeah, I saw some of those memorials. We just burned the whole place down, and then we're like, this isn't worth it, and then we left.
wrong. We burned your house down.
I saw all the plaques when I went up there, in memoriam of when the United States came up and burned everything down in Canada, and then they left. I
Not even.
almost verbatim. So yeah, probably not worth staying up there. It's probably why we left it.
But that's why your house is white. The White House is white because we burned the house. So they painted it white. It's actually the British who burned it. But yeah, it's the thing we hold on to.
The Canadians don't really have their own identity when it comes to attacking. So yes, they
No.
did it, but take credit. Yeah, I know how that works. I know how.
But go to Mexico if you want to. That's fine.
All right. All right, Arif, you ready? Sure.
I'm ready. Yeah, I'm ready. I'm sharing my screen right now. So basically, this is for the vehicle.py. BJ has challenged, or he asked us, or as a kind of homework, to solve the latency on the data that's being posted to the cloud. And so earlier it was for every minute. So all the data, the speed information that's been posted to the cloud is on sequence. So it's like synchronous. So he asked us to do asynchronous. I was thought of doing await, async await, but he also mentioned that the request library doesn't support async await on Python. So either you can go with threading, or I have to change this request library with something else to support the async await on Python. But I couldn't find one, or so he also said, since he insisted to go with threading, I want to explore threading. So I just searched online and found, what's that? Sorry. This one. So for threading, there were some examples available. I searched a couple of things, and this is the one I could understand. So I thought of using this. So basically, we have to import a thread, and then so in our case, we are going to change only the request dot post, because the rest we cannot change the rest because it will affect the simulation process. So the only location where we can, or I understood from his statement that we can make a thread on the request dot post, so that that will speed up the process. So what I did, this was the code that were present earlier. Basically, we have to provide the link, then arguments. The arguments here is headers, which is a token to log into the API, and the JSON.out. That's the data that we received, converted to JSON.out and posted to the cloud. So based on this example, I just now here they gave us 2-3 threads, so that each thread will run parallelly, so that will save time. But here we cannot do that. So I created only one thread because there's only one post. So what I did is just change instead of R, I just put B. Then I added this threading because Python 2, whatever the example I showed you is on Python 2. So in Python 3, they changed underscore thread or threading. So those are the two syntax for Python 3. So threading dot thread, I just added friend, and then I copy paste the same exactly, but only difference is it has to be a tuple. That is a syntax for threading. So I just changed the I just changed into this one into tuple. Then we have to initiate. So there's other syntax is we have to start that thread. So b dot start. That's it.
Yeah,
I can.
very well done, Arif. That's good. I mean, threading is one of the more difficult concepts that you can deal with in especially in higher level programming languages, because they tend to get out of hand pretty quick. One of the things I'll mention about this is it's interesting how you did that. So basically what you did was you just threaded the post, right? The HTTP post, and that's it.
Yeah.
And you said you only create one thread. Well, as it turns out, you actually every time you go through that simulation loop, you're creating a new thread, actually. And so
yeah, same thread.
It's a different
Thread.
it's a different thread.
Oh, but I checked by looking. I added some value like just b.native ID, just to find what is the thread number for that one. But it printed out the same thread number, and I was expecting more, but it's.
Well, so it may be printing out the same thread number, because when you set up a task like that to be run inside of a thread, it's only doing one thing. And when the just like if you had a single script, right, main.py, and you run it through Python, that is like the foreground thread, right? And the moment that the code finishes, that thread is done. So the moment that post finishes, that thread is completing. So probably what's happening is you're getting the ID of the thread, right? And by the time you go to start a new thread, you've already ended the previous one, such that the ID stays the same.
Okay.
Yep.
I see.
Yeah, no, exactly. And the other thing that you probably are finding is that if the server started backing up or was not able to process those posts quick enough, your simulation, your vehicle.py would actually just keep creating new threads, and they just keep stacking up to the point where your machine would run out of resources.
Yeah.
Right. I mean, and threads are not cheap, computationally cheap things to do, because you are taking a separate process that that your program is having to manage. Not quite a process. That's not actually spawning a separate process managed by the operating system. But you could do that too. There's a library called subprocess in Python, which will actually do that. Stay away from that if you can. That's really meant for running other programs or command line stuff from Python. But I think the big thing is that typically what we do is we don't actually spawn a new thread on the post. What we do is we actually build a queue. So what we do is we actually start. We have a separate little while loop that all it does is it just goes around, and what it does is it checks a queue or a list or an array, and what it does is a first in first out queue, and what it does is as that goes through, it just checks the queue, and if there's something on the queue, it takes it off the queue, pops it off, and then processes it, meaning posting, and then it just keeps going as fast as it can on that queue. But that way you only spawn one thread, and you know that it's only one thread, and it's only ever one thread, regardless of how much backing up you get. And then the queue just keeps getting smaller or longer depending on how long it actually takes to process. And so typically we do that because then it's only one thread to manage, and you can also manage, you know, how consistently you actually process that queue. You can also spin up new threads. It's like, wow, that queue's getting really long. Well, let me spin up a couple more threads to process that queue to get some speed, some parallel speed on that. So there's a couple of different ways to do that. So that's actually probably what I would say to make this even better, is to actually build an entire function which would then run as a thread. That would basically, as you go through, you just put the post body onto the queue, and then let the task that you assign to the queue just pull off, or assign to the thread, just pull that object off the queue and then post it. Does that make sense?
Kind of, yeah. Are we recording this one? Just
Let me see.
Yeah, it's recording.
something is not right here.
So I'm not sure what. Yeah, there's something that's empty there for some reason. Are you sure your backend and stuff is running?
Yeah, it's running. Yeah.
Okay. Oh, it just went really fast.
So I believe here I missed something.
No, go back. If you notice, it looks like it's actually going. It just went really fast.
Oh, simulated. So it started.
Oh, no, it started, but yeah, I don't know. I'd have to look at it a little bit more.
991.
Yeah, that is the thread. I think it should be a tuple. I have to call this so tuple. Something here.
Was this running before this exact code?
Yeah, it was running before. I could be able to do that.
Well, if it's supposed to be a tuple, then you probably need to put a parentheses around that request.post.
Yeah. So the tuple must be.
There, just probably comma after that, like put it back to the way that was, because that's part of the actual request.post. But actually, like, put a not right,
The tuple should have a comma, right? No?
no, not right there. That's just the URL. No, like right after the thread, you're gonna want to, yeah, you want to do it all around that entire request.post argument.
So the whole, everything is, oh, I see. This is a tuple.
No, that's just a function.
Yeah. I'm missing something here. Let me check. Yeah, if we just discuss on something else, I'll try to fix that and run it again.
Sure. So anyone else have questions? So to illustrate what I was saying before about that, about the um,
The threading?
yeah, about the threading. So if we're gonna, if we actually do so basically what we want to do is we want to create a task, right? And that task is what the function that you want to run in your thread, with a parallel process to whatever your main like function body is, or your main operation. So let's say you've got this, right? So you've got a while true here, and while true just means it goes forever, right? Like it's your main loop of your program, your main control loop. You're just going and going. And what we want to do is, let's say this line right here does something, and then here we want to, let's say like x is equal to 1, and then what we want to do here is we want to actually um, post, right? We want to do like a request.post, right? That x to some URL. Now this is more pseudocode than anything, right? But just hang with me here. So what we really want to do is we want to actually start a new thread. So we can do threading.thread, which is what we saw with the Reeves thing, and we could just pass task in with that, right? And this task is just the function task. And then we can, if this is our thread, we'll just say t equals, and then t.start. This will start this while loop that's just going round and around and posting over and over and over. Now we don't quite want that, because this is our main thing. What we really want is for this to only post when we need to post something, when that x equals 1 happens. And so let me do like a sim data equals simulate vehicle. Let's just say we have a function called simulate vehicle. It does a lot of stuff, takes a little bit of time, get some sim data, and we want to post that sim data. But we know that this post is going to take longer than we want to this simulate vehicle step is going to take. And so what we can do is, instead of posting it every time, we can just say q.push or append. I've been doing too much JavaScript today. Append, and what we can say, append sim data. Now up here, we can create just a list called queue. And a queue is just an array, right? But it has some special properties. You can do like a first in, first out. You can do like a LIFO queue, a FIFO queue, first in, first out, last in, first out, those kind of things. What we want to do is we want to push this sim data onto this queue. But then what we want to do is, if the length of the queue is greater than 0, then what we want to do is we actually want to queue.pop, and queue.pop will pop off the last element, right, of the queue. So this would be like a last, first in, last out. We don't really want to do that though. What we want is first in, first out. So what we really want to do is we want to access the first, or the first element of sim data. And then if it's that first element of sim data, that's actually what we want to send. And then what we want to do is we want to what we want to do then is we want to redo the queue to be queue of 1 to the end. So we don't want the first element. This is Python speak here. We're saying we're going to create a new queue. We're going to reassign the queue. It's not very memory efficient here, but we're going to reassign a queue and we're going to take the first element, or actually the second element because it's zero base index, right?
Second, the rest, right? Second and the rest.
And the colon is the rest of it, right? So we're basically popping off that first part of the cube. There's a more efficient way to do that.
I think you can pop the first item if you give it an element ID. I think you can pop 1 or pop 0, and I think it'll pull that first one.
Yeah, q dot pop 0.
Pop 0. There we go. So there, that's more efficient. And so we're just going to pop that queue's first element there. And what that does is it's just going to keep going around this loop while the queue is full, right? And all this thing is doing is just appending to that queue. So you have 2 parallel while processes that are going as fast as they possibly can. And it's everything that it's trying to do here to keep up with. This guy's just trying to keep up with this, because we know this is going to be faster than this. But as long as it can keep up, well, within a reasonable amount, all you have to do is append, which is a lot faster than posting, right? So we're just keep appending, and we don't really care about when the data gets up to the cloud. We just want it to get up to the cloud, because that's not a real-time thing. You can never guarantee real-time type stuff with the cloud. And so you're just trying to push this as fast as you possibly can, post it, and then pop it, right? And then at that point, it's like set it and forget, and you just keep going around. So it's kind of the same thing as what Areve had, but Areve was creating a new thread every single time. Whereas what we've done is we've actually taken the thread out of this while loop. So in Areve, in your vehicle.py, this while true is actually your sim step, your sim time. And you're going as fast as you can around. But we've pulled the thread outside of this while loop and created one thread so we can manage that thread a little better without potentially creating a bunch of threads without really knowing if they finished or not. The other thing that we can do with this is the issue that you might run into, Areve, is what happens if you get a 404 or some error back from the cloud? Well, you don't necessarily know if that happened because that thread's going to die. You have no kind of you really don't have any kind of recourse for that. So here you can actually you have a little more control over this. So now you can say, all right, if R is something bad, like r.status code is greater than 500 or 400, then maybe you can remediate that. Maybe you can do something with it. Maybe fix it, put it back in the queue to be processed later or something along those lines. Whereas before, if it died, it died. You had no way to control it, and you just lost out on that data, right? So that's kind of the simple way that we typically or not simple. That is the simplified way in explanation of how we typically will handle queuing, especially in embedded systems. JC does a lot of this. This is what JC spends a lot of his time doing, at least as of late, and that is writing queuing and threading inside of embedded systems. As those embedded systems generate data, you write to a data buffer, basically this queue, and then you just keep stacking that up, and you just process as fast as you can to send to the cloud, which is a very slow process on an embedded system. Because embedded systems are resource limited, they're not very fast. Sometimes you don't have internet connections and all that kind of stuff. So you kind of have to queue things up, and you don't want to stop your operation while loop because you are single threaded on an embedded system. You can only do one flop at a time, right? You can only do one calculation at a time. So you don't want, if you're waiting for that post, you don't want to block your main operation, because when you're blocking your main operation, it means you can't collect data. You can't do a safety critical thing, all those different things. And so you want to offload it to a process that's just kind of, waiting this 1 second or 3 second latency that's not affecting your main loop. No reason to block if you don't have to, right? So there's this is kind of what I'd say, Areve, your things on steroids, and how I would recommend it if we're going into production with something like this. This is going to be far more robust and probably easier to manage, and that. But yeah. So, anyways, that's my feedback. Did you get your thing wrong, Areve? You want to show it? I'd like to see how fast you got your simulation. You're muted.
You able to hear me now?
Yep.
Okay. So what I did is here, I tried something else and saved like that. So basically underscore thread. So this is what I was using. Then it's a tuple here. So everything has to be a tuple. So I just added a comma everywhere. So let me run that.
Yes, because go back to that, Arif. So
Yeah.
what you've done there is the argument to start new thread is a tuple, right?
Yeah.
A two-element tuple. And the first is a function definition.
Yeah.
Is request.post. It's
Yeah.
evaluating the function, kind of like what I showed up here, right? You're not evaluating the function. You're just saying, I want you to run this function. And then the second argument are the arguments to that function.
Yeah.
So that the thread, when it's executed, when it's started, it can then, do that, right? It can then run that function with those arguments.
So let me have this. So now you see it's going faster. It's not waiting for.
Yeah, much faster. But it's also way behind your simulation, right? Which by design, that's kind of the way it's going to be because it takes more time to post. But your simulation will finish, but you'll still see once your simulation finishes, you'll still see your vehicles updating, right?
Yes, that's correct. Yes.
So your threading worked. That's good.
That's good. Good job.
Thank you.
Well, it's great to see that. Good stuff. You guys learned something. That's good. As a teacher, that always makes you feel good. And I mean, you're now moving beyond just what we talked about in class. That's great.
Yeah, and threads are hard. Threads are not easy by any means. They're very confusing.
But it's the examples are available online now. It's I just basically copied and did some iterations. It didn't come first time, many errors, but it came.
That's our secret is we just copy and paste examples. we might just be able to do it a little more efficiently than someone with less experience. That's the only difference.
I like the reality, the expectation and reality comparison memes for programming, where like they show the expectation as this guy in a hoodie, right? And he's just typing away at about 100 miles an hour, and then it shows the reality. And there's somebody putting into Google like, how do you thread a request post, right? And then you click over, you go to Stack Overflow, you find the post, right? Copy and paste it in. There's a bug, so now you gotta edit a line, right?
Copy paste the bug on the Stack Overflow. Somebody have written an answer for that. That's
right.
Exactly what I did.
You got to read the tiny little comments right below because the real answer is always there. Yeah. Yes, exactly.
Follow the green tick. Yeah.
Right, exactly.
DJ, have you seen the machine learning meme where it's the professor is supposed to be kind of standing up in front saying, changing your code really quickly, not updating it, that's very bad practice, and then it says, if you do it really fast, though, it's called machine learning.
Yes, exactly. I haven't seen that, but that is exactly what it is. That's good. Oh yeah, that's the thing, guy. And you may feel like beginners now. You're spending a lot of time on Stack Overflow, but JC and I we'll attest to that. I mean, we're pretty seasoned, but we spend most of our time on Stack Overflow. I just did like a new system today, and I spent half my day on Stack Overflow. It's just the nature of the game. You just may be able to do a little more efficiently and find your answers quicker because you have more experience. But that's really what it comes down to. And I'll even go as far to say that I'll still do things very inefficiently to get it done. The only difference between me and maybe you is that I know that I'm doing it inefficiently, and I'll say, yeah, I'll come back and do that later. You may not realize you're doing it inefficiently, but we both still end up in the same place with the same shitty ass code. So, I'm not sure if that really means that, what you guys are doing is any different than what I do. So, I mean, That's just the nature. I just may know that I'm doing something shitty as opposed to, you know.
You just know better and still do it. We don't know any better.
Yeah, exactly. So as long as you get the work done, that's all that matters, right? So that's really what it comes down to. So I wouldn't be afraid to, you know, uh, to uh, just dive head first into this stuff because that's what it is. Expectation versus reality. Cool. So any other questions, comments? We're on our last week, guys. So Thursday of instruction. So what? Thursday's our last one. We're not going to code at all. I mean, unless you guys have questions or want an example or something, but it'll be like tonight. Um, we're going to go over advanced deployment concepts, more lecture format, just so you guys know some of the words and are exposed to it. You have everything you need. It's just more tools. We'll go through some of the dashboards like AWS, GCP, things like that, just so you see them. I'll point and click on a few things. Talk a little bit about Kubernetes, things like that. And then JC and I will both do best practices and kind of going forward, things to watch out for, stuff like that. And then, we'll cover basically what happens. So we don't go away after Thursday. This is really the beginning of the journey, right? So this is where you guys decide what you want to do, and pick your own project. We also have work that needs to be done, so we're starting to kind of beat the drum on that. All of you have done exceptionally well, so you guys just need to Slack me. You can either tell me on Thursday or tell JC, or Slack me individually or whatever. If you're interested in doing other things, whether that's shifting your career or just moonlighting or just being like, hey, I just want to stay involved in this and have fun. Do you have a project that I can work on? Or, hey, I'm thinking about what's even better. Hey, I'm thinking about this project. What do you think? Would you like to help me with this? And we'll help you. Like, that's what we want to do, because I've had some really good experiences doing that with previous boot camps, and that is, one of our boot camp guys who has worked with me and JC for 3-4 years now, Michael. He went and did his wife did like a LuLaRoe or something, like a clothing like MLM thing, and she needed a website and to sell her clothes, and he was like, all right, well, I'll just go and build this website for her, little e-commerce site. And he said, yeah, you could do Shopify or something and put our Etsy or whatever, but I just wanted to build it. Turned out our business boomed, and because he built that, and he did it, in a month or two. I helped him through it, and Andy did too, and it was great. I mean, and now he's switched careers completely from mechanical engineer to he was like doing machine shop stuff, and he now is full-fledged full stack developer. So just picking a project. It could be as simple as an e-commerce app that has been done a billion times before, and you don't necessarily have to redo it, but you can. Or talk to us. We've got a lot of stuff, a lot of things in the pipeline that you can take her around with, stuff like that. And then, like I said, we're also beating the drum to actually get some paying gigs too, which is always a good thing. So, yeah, if you would and you're interested. The other thing is you may be like, screw this, I'm done with this, I'm just glad I had the experience, but whatever. You don't have to talk to me then, whatever. Have a great time. But if you do want to, private message Justin or I, and tell us what your plans are, and we'll make sure that we make it happen for you. Because we've invested as much as you have invested in this, I think. So at least that's how I feel, and I want to feel that way because, we weren't just, obviously we didn't do this for the money. What we did was we wanted to train you guys, right? And make you valuable to us, but then also, I think there's also a sense of altruism, at least for me, and that is I think more engineers need to have these skills. Regardless of if you use them or not, you need to know that they exist, and you need to know how to manage them and kind of open it up. Because right now I think there's a massive gap. Jason and I talk about this all the time. There's a massive gap between the really tangible engineering like mechanical, chemical, electrical, design, right? And then the software engineers or the software developers. There's this gap in between, which is where all the magic happens that no one really knows about, right? There's very few people, and that's the niche that we're trying to fill. And the more engineers that we train to be able to do that, I think just the better for I guess society in general, right? And technology and betterment in general, because we're filling those gaps. So um, because it's that integration step, right? There's an argument to be had. I've heard the argument that says we figured out pretty much to the depth of the science that we can figure out right now. We're pretty much at the limit. What's left now is the harder thing, and that is combining those things together and integrating those things together to create new science. And that's also, I think, why we've seen a plateau. Beth Ann and I work a lot with predictions using machine learning to predict future technologies. It's another cool one that you guys might be interested in. And we've been seeing a plateau, right? And even in the, like, I would argue, even in the last 5 to 10 years, we start seeing a plateau in technology development. There's not really been anything disruptive. I mean, you could claim social media, but that's more of a social phenomenon. The technology is pretty much the same, right? It's how society uses it, but I mean, that's to be expected. We're not seeing a significant amount of boom or anything. It's possible COVID will have changed that because that's like a structurally changed, so you saw World War II, right? World War II completely shifted the way we did technology. Um, War is a great thing for technology, awful for humans, but great for technology development. Um, and so, maybe COVID will take that place, but we don't know yet. But we do see a plateau, right, in development. I think that there's a massive opportunity with integration, system integration, things that we're doing that's putting the computing with the mechanical, with the machines, with everything to actually move that forward and open up the new avenues of discovery and stuff. So, anyways, that's my soapbox on what the system integration thing, why I like it, why I've spent a ton of time thinking about it and pursuing it. So hopefully you kind of share the same kind of feeling. So it's very few people that are able to do kind of both and have the depth of knowledge in all the fields to be able to do that. And it starts, of course, with the fundamentals, which is what we kind of taught here. You guys already had the fundamentals on the other side. Let's get you some of the fundamentals on the computing side now, so we can start connecting them. So, anyways, that's the soapbox for tonight, I guess. JC, you want to soapbox anything?
You said it just as well as I would, if not better. So
Great.
great job, guys.
Definitely.
I agree. I mean,
He's saving it all for Thursday.
I hope so.
yeah, I mean, thanks for mentioning this, and I wanted to share in a way my experience. Like when I started with this boot camp, I think probably on the first day I explained, I've been all through my life mechanical design engineer, right? And there came a point where I felt like there's some stagnancy. You're not like really churning your brain. What I'm doing day in, day out is we have design guide, a lot of thumb rules and specs and all we're picking up and just applying it and, creating our system. And you keep on hearing all this buzzword every day, the IoT, which thanks now I know I should call it, whenever I'm talking with someone, I call it analytics of thing and not IoT. Yeah. So that was the whole reason I thought why not try? I mean, but I should say that I don't know if I would have done it with someone else, maybe it could have been the case where you said, oh, enough of it now. I know I'm going to go back to my thing. But the way this boot camp was conducted, I should surely, say yourself and Justin created the right amount of interest in me. I'm sure it would be same for everyone else. The way we did it, the way you guys did it, it's not, of course, I go back to many YouTube videos just to pick, few things. But it's completely different. It has created that interest, and thanks for sharing this part that if we want to continue to learn as kind of a side thing in future, if we reach out to you and if we get some small pieces, we can try to work on it and hone the skills basically. I won't say hone the skills, just develop the skill, because we are way away from it. But yeah, because the real challenge is learning and then trying to create your own project immediately. We may not be able to come up with a problem for which a solution has to be created. But if there is something else, I mean, the team needs, and if we can chip in, use that to benefit ourselves, just to improve on what, or take it from what we have learned now. So yeah, thanks yourself to you and Justin, the way this has been all put together, I would say.
I appreciate that. Yeah, I mean, it's obviously not a small amount of work that goes into this, but at the same time, I also think that that we always battle with how much is too much, because and I think that we flirt with that line a lot, and oftentimes we go overboard sometimes because with just too much. But I always remind myself when I'm doing that, is that, look, going through the 4 hours or 3 hours, you're not going to get it. We know that. That's not the expectation. The expectation is that if you want to get it, you're going to go back and review it 2, 3, 4, 5, 20 times, and it sounds like that's what you're doing. So by design, I'm really happy to hear that you guys are doing that, because that's how it's designed to do that. And yeah, you won't go back through and do it every single time, but you'll remember that, hey, I heard that in week 6, 7, or 8. Let me go try to find that somewhere, right? And then you slowly kind of pick that up. So that is by design how we do that. So I really appreciate that feedback, and I'm glad that it worked that way, because that, like I said, is flirting with that line. That's a pretty tough thing to completely. There's a Beth Ann knows this as a collegiate educator, right? There's a fine line between teaching and demoralizing, right? And that's the line that we're flirting with. And I'm sure a lot of times through this 12 weeks you felt demoralized. I get that. But I'm hoping at the end you're like, yep, I conceptually get that, and I can figure it out if I need to. So if you still feel demoralized, let me know, because that would not be a good thing. But yeah, that's hopefully we somewhat skirted that line of demoralization and teaching.
But you do a really good job in helping us to understand, for those of us not comfortable, that you don't have to grasp it all. You can get little pieces of it. You can work on, you could, if you want to be good at the front end, great. If you want to be good at the back end, great. If you want to just try this part of it, great. That start with small problems. You don't have to try and solve. I mean, one of the things that you said to me was, don't try and solve problems that have never been solved before when you start. Try solving things, or just improving on little things, or you've been very good about helping with just try it, just get your feet wet, just go ahead and do it. You don't have to, we don't expect you. And that's really helpful from our side, is because it doesn't feel as overwhelming. Like when you guys go through it, yeah, you're buzzing through it. And at least I'm sitting there going, okay, I'm totally lost. I'm sort of getting it, but I'm totally lost. But then I'll go back and I'll think, okay, it's okay. I can go back and watch this. I can go back and read it. I can go look up things online. I can go, it's okay. It's the fact that whereas, I mean, that's partly what's valued to me when you say about too much, is that when I sit in a classroom, I'm worried about, okay, I've got to stop right now and make sure that you understand right at this moment. I can't, because you don't have the same opportunity to piecemeal it.
Yeah. Well, and that's the other thing, that why I love teaching your demographic is because in a, even graduate level, but especially undergraduate, which is a whole other ballgame. You guys all remember, we were all there at one point. You have to take an exam, right? And that means you got to understand it for that exam, and you only have a few weeks before that exam to actually make sure they understand it. Whereas, and you can be guaranteed that half the class doesn't care to be there, and they're just there to, well, I don't know why they're there. So I guess wasting their money. So, I mean, in the end, you guys actually want to learn this. You're here because you want to be. And that's a huge difference. I don't have to worry about writing an exam to test your knowledge. Like you guys are going to get flying colors from us, and you'll probably get a certificate from a university if I can work that out. So, for completion. So, I mean, it's this kind of thing that I'm like really, that's why I really love teaching these types of things, because you guys want to be here. It's also why I like teaching graduate courses, because typically there's a higher percentage of people that actually want to be there, if not every single person in that class wants to be there because they chose that. They're there for a reason. And that's a huge difference. But yeah, Beth Ann, you teach mostly undergraduates, right? So, or at least this semester.
Actually, I teach mostly graduate students who don't want to be there.
Oh, okay. Well, perfect.
I teach some undergrads too who don't want to be there, but it's the grad students that don't want to be there that are most painful. The undergrads, they kind of like they're too stunned, but the graduate students are all like, I just want the piece of paper. I don't care what it means. Just give me the piece of paper. And you're like, okay, no, I can't do that. And yeah.
So I'm teaching this semester down in Texas, systems architecture course, and I'm recording this, so I won't get too detailed. But I was told that I made 2 students cry by a homework. Yes. Now, this is a first-year master's level systems engineering course, graduate level, and they're crying. So there's either something is totally wrong, or I'm just awful, because I can't imagine that. The homework that I gave, we were using Sumo. I actually assigned Sumo. I gave them like hours and hours of video content in lieu of a textbook. Gave them 3 weeks to do this homework. The average, I guess, the lowest amount of time we took a survey after. The lowest amount of time was 6 hours they spent on the homework, which is good. 3-week homework, 3 credit hour graduate course. So this is a pretty serious, graduate course. Average was like 13 hours. So you say 3 hours outside of class, right? So for 3 weeks, you'd expect an average of 24 hours spent on homework. And then there were those that said they claimed they spent more than 50 hours on the homework. I don't know how you do that, but that's not true. But you might feel like it, but that's not actually true. But yeah, I feel your pain, Beth Ann, because about half that class has decided that they don't want to be there, and it's unfortunate. But I don't know why you do that.
But that's a changing group of people too. That's one of the problems, is that most of us, we weren't spoiled, and I just mean that most of us, we earned our degree and nobody spoon fed us during, and the fact that we're here is indicative of the fact that we believe we need to keep learning. Yeah. There's some people that believe that I'm going to get an A and I don't need to learn it. I don't need to put any effort into it. And that's just.
It'll be interesting. All our kids are going to be sitting here in 30 years saying that the generations, 20 years younger than them, just, actually, we're too spoiled or something. So. It's a vicious cycle. Vicious cycle. We all grow up at some point, right?
Eventually, the technology will plateau completely, and no one can get any better, right? We can't get any more efficient, and they can't get any softer, right?
We literally can't. I'm a big Star Trek fan, and there's a really interesting little thing. This is like started Next Generation or whatever. But there's a 6-year-old and the dad. They're just walking through the hall. Like split scene, kind of total passing thing. But the kid's complaining. He's like, "Dad, I don't want to do my calculus homework." The kid's like 5 years old. But like it just showed like what the vision was, is that we've gotten so efficient in education and brain development that they're taking calculus at 5 years old. That's stuck with me since I probably when I saw it when I was like 12 or something. But yeah, I mean it is interesting to think that at some point it'll just plateau and just also maybe we'll just get all Elon Musk's Neuralink and it'll just be injected in the back of our head and we'll just know stuff, right?
Wait, we can't just think that we know things? That's not good enough anymore?
Not good enough anymore. Yeah, you have to.
That's what the undergrads keep telling me and the grad students. It's okay. I don't need to write this down. I already know it.
I already know it. Yes.
I can think I've got it.
And I think that's what this, to me, a lot of it was, this class kind of helped, all the things that you didn't know kind of thing. And it's just, there's just so much out there. And it kind of gives you at least the flashlight to point you to topics to go look at, which then you just kind of peel it back a little bit more layer by layer. And you just keep learning more and more. So I think that's really what I got out of it.
Yeah, that's the goal.
And JT, getting on that, actually, BJ and I had the exact same conversation on how that was part of our goal, was to make sure that everybody at least got to the point where you know what you don't know, right? Because it's once you know what you don't know, then you can actually figure out how to know what you don't know, right?
Yep. And that's why seniors graduating from undergraduate are the most dangerous at any point in their life, or at that point, because they don't know how much they don't know and they think they know everything.
But I tell you, one of the other things that was really helpful is when you guys were debugging things. Like that actually was one of the most helpful things, is when you'd go, okay, I need to go to Stack Overflow and look this up, or I need to go and that was so helpful, because it meant even with all of your expertise and your experience, you still had to go through those steps. So the fact that we have to go through them made me feel a whole lot better.
Maybe that's part of the
Watching you mess up made me feel so much better. Thanks.
It sounds like we should prepare less, right?
We should, JC. I think that's a way to prepare less. We'll just stretch them into 6-hour sessions as opposed to 3.
Like I don't know what we're gonna make tonight. We'll get somewhere.
We'll figure it out. That's exactly. In fact, that's what I told JC, was like, hey, don't worry about, when we were first getting into this, don't worry about making a mistake, or like, don't worry if it doesn't work. Like, doesn't matter. Like, they actually learn. We've been told this multiple times from multiple sessions, and even during class when I do live coding, for my graduate courses, they like it when I mess up. And I think, one, it makes them feel better, but two, it also shows problem solving, right? Like in a really tiny little kind of example of how did he solve that, right? Or how did he approach that? And it kind of gives you, kind of a, I don't know, just an example of, how the approach is, kind of real world sort of things. That's what I've always been told. So yeah, I appreciate that. It's, that's a very, very common feedback that we get. So I do make an effort, sometimes to mess up intentionally, and go to Stack Overflow. Maybe not mess up intentionally, but I don't try to hide it, let's say, as much as I used to. I've done some growing in that area. I used to try to hide it, and that's not good for anybody.
Yeah,
I'm just
yeah, go ahead, please.
No, I was going to say you could do that in front of your students that cried and then just start crying yourself. Just see.
If students cry, I was told they cried. They didn't actually cry in front of me. I don't know what I would do if a student cried in front of me. I'd probably just turn around and leave, because I'm an engineer. I don't do feelings, so I'd probably just turn around and leave. But yeah, maybe that's what happens next time someone starts crying in front of me. I'll just start crying and see how they react.
The way I dealt with it was to say, I had a student cry in front of me once, and I said, I'm not equipped to deal with this. There are counselors. There are people that can help you, but I'm not it.
Not me, right. My training is elsewhere. All right. So any other questions, comments, concerns? Otherwise, we'll call it a night. And then go for Thursday. Thursday, I don't think will be as long, unless we make it as long. But I don't think so. So we're not doing any coding. It's mostly going to be discussion. I would, think about feedback. And what we'll do is we'll do it in 2 parts. We'll do a recorded part first. So if you want anything recorded, it would be great if you have nice things to say. Say those then, because we'll ask you if we want to put those things up, or put a little montage together for others in the future that might want to see it. We'll verify with you before doing that. And then we'll stop the recording. And if you want to give feedback that you don't want to be recorded, or that's actually the most valuable to us, because we want to know where we screwed up and what we can do better. Because that's the only way we do this better, is to get that feedback. So pick and choose. You'll have both opportunities. So just think about over the next couple of days what you want to say, and do that. The other thing is obviously we're always on Slack, so load it up in a DM. That's perfectly good too. So
I do have one question for you about last week's lecture.
sure.
Not last week's class. You talked about when we were doing the machine learning, and you said you were talking about that a lot of it, once you set it up, is kind of plug and play. And the question I had was about how constrained are you by the data? So in this case, you made up the data and then you essentially put it in and it showed you, but how important is the data for you when you're trying to do?
It's everything, right? I mean, the data, literally in machine learning, the data is everything because of how plug and play it is and how standard it is. Literally, that dot fit function for every possible machine learning algorithm, that toolbox in scikit-learn, which are orders in the hundreds of algorithms. I mean, it's all about the data, and that's why you end up for your data. Your tuning is what takes the most time and is the most frustrating because I mean you're saying like which features do I need? We got a really nice toy canned problem that I made up, right? Where the data was perfect for the problem. And even then, I don't even think the data is that perfect. If you actually try to write some more and you've made some more, it actually does go off the rails at some point because I tried it and I stepped it back to what we looked at in class. So yeah, I mean, it really comes down to your features, what your data looks like, what your pipeline looks like, and how you're structuring all of those things. And then what algorithm works best for your data. I mean, that's the other thing. There's a nice little matchmaking that has to occur, and there's a significant amount of work that's being done in research right now, which I've kind of gotten into recently, and that is developing machine learning models in order to predict what model is best for the data that you have. So it's like a meta level of machine learning. It's interesting. It's got a lot of sometimes they're called learning machines or there's this whole IEEE fiasco that happened a couple years ago with plagiarism and stuff. But extreme learning machines, ELMs, you'll hear there's a whole nother area where they're like self-assembling, where they'll self-assemble. Um, Generative adversarial networks, GANs are very good at that. That's actually most of what you see, like AI that creates paintings and artwork and stuff. They use generative adversarial networks where one generates data, the other trains on the data, and then they actually fight back and forth until they reach an optimal solution between them. And then they that's the model. That's the trained model. There's so many different things and different structures out there for that. But yeah, so even Technicity, JC and I developed some stuff around. I can't get into it because of the IP around it, the trade secret around it. But where you actually do create a machine learning algorithm, a neural network that actually is able to be trained in order to know how to develop your data, how to pick what features are important.
So mostly do you have people that come to you and your clients provide the data and you just figure out what to do with it? Or is it that you guys actually have to figure out what you have to gather?
It's a mixed bag. It really is a mixed bag. Most of the time, the reason that we teach IoT and connected systems is most people should already have data, but they don't. And so they're looking to get data, which is why we're forced into developing IoT systems in order to get to the things we want to do, which are the analytics. So not the AOT, right? That's where we want to get to. What I always tell someone is that they come to me, it's like, hey, we want to develop an IoT system. It's like, well, you're about 5 years behind, so we better hurry you up. That's why we have to be so rapid in deployment and development. Other times you'll have very large organizations or even smaller ones, but they have data, but it's such a mess that you spend 6 to 8 months just processing the data to a point where you can even start to use learning techniques like supervised learning, like k-means clustering and unsupervised learning to like do principal component analysis and those types of things. So it's a mixed bag. It really just depends. I would say it's a more common to see people that need to get data than it is people that actually have data. And of the people that actually have data, very few of it is actually usable without significant investment into that. That's also why you see these very, very large enterprises developing that, they hire massive data science teams. There's 25 people in the data science team because, well, they got this grandiose title, but all they do is they write Python scripts and deal with Excel spreadsheets all day. And it's not even Python scripts. Half of them don't even know how to write a line of Python. They just deal with Excel spreadsheets all day. So, sorry about that. So, I mean, that's just the nature of the game, right? So yeah, total mixed bag. Really, really just depends. And a lot of the stuff that you guys might want, do, like we constantly have needs for people just do data processing. It's not here. It's the heroes we need, not the heroes that you necessarily want to be. But I mean, that's just the nature of the game. But yeah, I mean, that's a good entry point too. The other thing that's kind of cool, like a little project that I did was built a little machine learned model on my garage door. So like if you have little IoT things around your house that you can get data off of, typically they all have little data that you can download or something. What you can do, like what I did was I built a model. So I have this garage door opener that all it does is report. I can't control it or anything, but it reports every time it opens and closes. And so I ran it for like 2 years, and it's not my garage door, it's my wife's garage door. And so what I did was I took all that data and I trained a little logistic regression, and then I set it up, and it would text her in the morning what time it predicted she was going to leave that day, based on the weather, based on the time of day. And this was before we had kids, so it was pretty it was pretty easy to do. With kids, it's all out of the place. I need so much more data, but yeah, and then she got creeped out, so I had to stop the text messages. But because it was really good at predicting when she was going to leave, and so like those little things, it was like a 3 or 4 hour job, but it was kind of cool, and it was really impactful. It got her really pissed at me. So I was doing something right, I guess, right? So so there's another example of something you can do, right? If you have like a little thing that you can get some data on. Just collect the data, process it, and write a little rule base or write a little machine learned model to do some prediction on it. All right. Anything else? Sweet. All right, guys. Well, we will see you on Thursday then.
Thank you.
Nice work. Thanks for showing us your threading. Really cool stuff.
Yeah, that was awesome. Good
Yeah,
job.
good stuff, man.
Yeah, nice work.
Hey, guys.